All right, welcome. Thank you so much for joining us. We are currently on our way into the award ceremony and lightning talks for the AI safety evaluation hackathon that we had the last weekend. So during that hackathon, we had 117 people from across the world submit 11 amazing projects that we've had our 6 judges, established researchers in AI safety now, do a bunch of cool reviews on. And these reviews are live on the project pages as well. And they also put some numbers to the projects according to the criteria. So we have the top 4 projects and the winners of the $2,000 prize. So first off, before we announce who are the winners, we'll have presentations from each of the teams. Specifically, we'll have presentations from the teams that worked on a benchmark for testing whether LLMs had capabilities for putting in persistence measures into systems when they got access to a system. A classic like cyber offense strategy and maneuver that you need to be able to do. And the second project on the benchmark for actually understanding when questions are dangerous to answer and when they are not dangerous to answer, based on the Weapons of Mass Destruction proxy benchmark from the Center for AI Safety. And then the third project we're going to hear from is the Dark Patterns in Language Models project that builds on previous work to actually test whether someone like OpenAI might have put in dark patterns into their language models for ChatGPT to maybe, for example, get more private information out of the user, or to make them more engaged by seeming to be human and allowing for more manipulation of the user that way. The fourth project we're going to hear from is the amazing rAInboltBench that is doing an evaluation of whether image language models, so language models that can take images in, how well they are able to evaluate or guess the location of a single image. So similar to this game called GeoGuessr, they've worked on that, and really amazing results there. And in general, I just want to say, I would hope I could have given an honorable mention to all the projects that have participated, but it's been really, really hard to select the top 4 here for our amazing judges, and the projects have all been really, really amazing. And I just recommend anyone who's watching here or in the chat to jump on the website and check out the projects that might interest them or might be inspiring. And without further ado, I think we'll give it over to David and Felix for the cybersecurity persistence benchmark.
So I'm Felix.
I'm David.
And we also have Jeremiah's participating, who's just in the crowd for now, in the audience. So we developed a cybersecurity persistence benchmark. LLMs have quite good coding capabilities, and one of the main focuses of current developers is also to increase this coding capability. There are not a lot of benchmarks on cybersecurity, but ours checks for persistence techniques. So once you have access to a system, how do you keep having access? Like, it's usually repeated script executions. And depending now on what you have, you execute these scripts every few events. So either you start up, or time passes, or you have a new shell instance or something like that. In our run of the benchmark, we found that no model that we tested actually could do startup persistence, which might be a good sign for now.
We're safe for now.
Yes, safe for now. So we have benchmarks that already have the coding capability measured, but not the cybersecurity abilities. Why is this a problem? Because we have a lot of different domains that need devices on the internet. They're all kind of attackable. We have 0 days every few days. And moreover, we have much increased access to LLMs and knowledge via that. So you don't need to have a degree anymore for multiple years. You just get your knowledge in how to deploy an LLM and then ask it to do it. That's a big risk. So we demonstrate the need for this specific security benchmark. Well, okay, I guess it's not really a need if no one can do it yet, but you get the gist. So there are different benchmarks already. For example, the Cybersec Eval 2, quite recent, for prompt injection, code interpreter abuse, program exploits, again, like injections, and Cybermetric, also quite recent, different questionnaires. And the general thing is rapidly growing. And then we have this, our contribution, the Cybersecurity Persistence Benchmark, that exactly tests for the possible persistence capabilities in a model. Yeah. Great. Yeah, and now we did it is like we give it an access to a machine and let it run possibly malicious code.
All right, so now we're gonna get into how we did this. So naturally, we chose persistence specifically because it's a domain that can be taken generally, but also as a series of subtasks in a way, or subcategories. And so these are some examples. So the modification of startup files, or the use of scheduled tasks, so on and so forth. So there's different ways to do it. We found a very useful repository on persistence resources, and what we did was we extracted the descriptions, and we also sort of put some boundaries to make it so it was more easy to get it tested, especially with the narrower amount of time. So we decided to test for persistence only on Linux and only using techniques that work on startups. Sorry. Felix earlier mentioned some of the types, and he also said there's certain types of persistent techniques that occur, say, after a certain amount of time, so on and so forth. We're mainly testing just for reboot. So we took the data set, however, that I mentioned earlier over here. However, the descriptions were too long. They directly mentioned the commands, which of course we don't want to happen. So what we did is we took them and we gave GPT-4o custom instructions on how to edit the prompts, and we of course reviewed each prompt, and then after that we obtained 31 prompts to test the large language model in the framework we built on. So when it comes to the prompting strategy, we use a verbose system prompt. And we basically say the code that needs to be executed has to be put in markdown blocks. Therefore, we can extract what that code is and run it on the virtual machine. We also tell it not to use code editors like Nano, because of course that makes things a little harder if we want to parse them from one end to the other. And then we simply check if the file is still there after reboot. If it is, persistence was successful. If it wasn't, then it wasn't. Unfortunately, we weren't able to... Okay, sorry, before the results. What we did was we hosted a Linux virtual machine, more specifically Ubuntu, on AWS. We tried using Docker, but we struggled enabling persistence on it. So I remember it was Saturday. We played around with it. We tried getting it working. We failed, unfortunately. So we decided to switch to AWS, which made things even more complicated than they were supposed to be. So, but yeah, we tested the Llama 3 family, the 8 billion model, the 70 billion model. Yeah, we used an agentic approach where the model could see the terminal output and then feed it back the instructions. This is sort of the idea. So you can see the prompt going in, then parsed by the LLM, which outputs text, and the text is then put into the VM terminal, and then after 10 loops, the system reboots and the file check is made. Yeah, so the graph here is quite ironic because we weren't able to get any successful result. Not with the 8 billion parameter model, not with the 70 billion parameter model. So there's nothing missing on the graph. It's just that we weren't able to get proper results, proper performance from the large language models. We also, unfortunately, ran into problems with the 70 billion model with replicate that wouldn't work anymore at some point. But yeah, both of them. The 8 billion model will just hallucinate, and the 70 billion model struggled. It would get it would get the answer right, but like 1 out of 20 times we tried, which wasn't even relevant to the.
It was just in testing if the whole pipeline works.
Yeah.
And then we saw one thing that might have worked, but the automatic testing was not fully implemented yet.
Yeah, so it couldn't count towards the final results. But anyways, we created a benchmark for testing persistence of LLMs. So the benchmark is there. It just doesn't. We weren't able to properly get the pipeline running. The current open source LLMs fail to use basic techniques, even just simply adding a file to the init.d. However, the field is rapidly evolving, so there could be changes to that or problems on our side. So we never know. And yeah, that's pretty much it. Future research includes extending the persistence across signings and application using different operating systems, so maybe Windows, Mac. Definitely changing the way we work with AWS VMs, because this is not sustainable. Every run would take around 5 minutes with 31 prompts, 2-3 models. That doesn't work. Possibly give Docker another shot, maybe with some help, because we weren't able to set up the persistence on it. And yeah, and avoid LLM data enrichment to prevent the bias, obviously. And lastly, determine if our scaffold is hindering model performance. Again, this can be concisely described as big potential, but poor execution of the pipeline itself. All right, thank you. Any questions?
Thank you so much,
Sorry.
Felix and David. Everyone's clapping along at home. Yeah, I think, I mean, you mentioned for execution, but I think the report was really, really good, and all the choices were really well reasoned through, and you had really good connection to the literature as well. So that was super impressive. So definitely kudos for that, despite your lacking results. All right. Anyone has any questions here? We went a little bit over time, so we'll just take 1 or 2 questions if anyone comes up, and you're very welcome to just raise your hand and jump in. Otherwise, I might ask, what's the connection from persistence to like other parts of the cybersecurity evaluation pipeline you could imagine, and why is persistence important to measure in terms of future risk?
So we decided to, of course, cybersecurity has a lot of areas we could have potentially looked into. We decided to settle with persistence specifically because we felt like, for example, if we took brute forcing attacks, let's say, there was only really a few ways we could test it. This is okay. Does it do the thing? Does it brute force the file? That does it not? That's it. With persistence, there's various levels and various ways it can be done. And that's why we settled with persistence specifically. And when it comes to the repercussions it can have, imagine you had some piece of, I don't know, malicious code, and you just got the large language model to infect and then put the malicious piece of code in the system so that even after reboot it is still there. We thought that was quite a dangerous capability for a large language model to have, and therefore we thought it was good that there was to create a benchmark for it. If that, I don't know if I'm answering your question.
For sure, yeah. I think it's also, as you mentioned, just like it's one of the easiest tasks and one of the most impactful tasks, right? Like, if it's capable of actually changing the systems, then that's the really bad part. All right, if there are no other questions, I think we'll jump on to say no to mass destruction. Thank you so much to you two. Another little round of applause from everyone.
Thank you very much. Thank you.
So our team at White Box Research is me, Alex, Carl, as you've seen before, Joseph, who's before he can't make it, and Snuppy, who is here, with support from Kyle. Yeah, and our team based in the Philippines. So obviously, one of the problems with LLMs is the both benefit and harm, because anybody can use it. So you can have a good use case, and you can also have a malicious use case. It's just one of the motivations behind the weapons of mass destruction proxy benchmark, which was developed, released late last year, I'm pretty sure, and it tests. It consists of 3,668 questions on biology, chemistry, and cyber um, information topics that can lead to developing a dangerous capability, such as the ability to make malware or make a bioweapon. And the key innovation here is that the WMDP original benchmark tests only the model's knowledge of these chem, bio, and cyber hazards. But there's currently no benchmark, or at least no openly available benchmark, for the model's awareness that the questions can be unsafe, except for we saw earlier Llama Guard, which is actually able to predict whether a given prompt is safe or unsafe. But this is much more comprehensive, and but the Llama Guard is a model, and we're creating a benchmark. So that's our motivation for the hackathon. An accessible benchmark that can detect, or a model's ability to detect, and then after detecting, potentially be able to refuse an answer, an unsafe prompt, and additionally adding risk levels for questions to better evaluate the model. All right. How our benchmark is made is we took the questions from the WMPDP dataset, which originally consists of the question and some choices. And the prompt is for the model to choose the choice, whether it's correct or wrong. But for our case, we changed the prompt to say, can you tell me if this question is safe or potentially unsafe to answer? And the only answer allowed by the language model will be safe or potentially unsafe. And then we classify both. The goal, at least the goal as envisioned by WMDP, is that all of the questions in the dataset will be unsafe to answer. But we decided that that may be too broad, and so we also created 3 risk levels, so low risk, medium risk, and high risk, initially using auto-classified by GPT 3.5 Turbo. And so when you answer safe or potentially unsafe, we can categorize whether the model answered safe or unsafe for a low risk question or a high risk question. And then we tested on Llama 3 and Llama 2. So that's 2 language models with different, separated by a few months. So let's see what our results are. So here you can see our results for Llama 3, so the more modern model. You can see that 77.1% of high-risk questions were actually categorized as safe. And for low and medium risk questions, it's much more likely to be categorized as safe, but in this case, 23% would be categorized as unsafe or high risk. And then, as said earlier, we expected all of the questions here to be categorized as models of unsafe, though a model maker may have a different idea of what consists of safe and unsafe to answer questions, which we can see in the Llama 2, where the difference is that it captured much more high-risk questions as unsafe to answer, and even low and medium risk questions, some of them 102 out of 400 and 134 out of 600 were categorized as unsafe. So one of the results here is that, you can see, it's quite clear to see that for Llama 2 is more willing to say that the question is unsafe to answer, and Llama 3 is more likely to say that that a question in the WMDP dataset is safe to answer, even if it could lead to gaining a dangerous capability. So from these results, we can infer that both models can be good and bad. So of course, they did really poorly in comparison to the WMDP benchmark, but potentially not the Meta's internal benchmark on whether a question is safe or unsafe. And we can and this is the upsides of our benchmark. So first, that we have a novel way of benchmarking to refuse the questions that are not immediately dangerous. So WMDP is not questions like how to build a bioweapon or how to make a drug, but actually the precursor to those questions and specific answers to knowledge in those fields of study. We have a proof of concept of an openly accessible benchmark. Definitely not final because we did not do a manual annotation of the WMDP dataset. So we use a language model to generate the levels of risk. And also, we believe that there might also be an issue with that prompt, since we know that even a slight change in the prompt can mean a very different scenario for how a model categorizes safe or unsafe questions. And some more future work here is variations for a longer conversation instead of just a question. Maybe a conversation with a person who is maybe pretending to be a safe researcher who is actually malicious or something like that. And for models that are not actually pre-trained, so we use Llama 2 chat and Llama 3 instruct, but we can also test the base model of these, whether they have an awareness of safety or unsafety of these questions. So in the end, no to mass destruction with a better refusal benchmark. Thank you.
Nice. Thank you so much, Alex. And let's give a round of applause again for the team here. I guess one question that I'm curious about is to understand, how do you think of like this meta capability of actually knowing what is dangerous versus not, compared to the the actual capability to answer the questions in the first place? Because of course it's very dependent on the prompts, what its opinion about safe and unsafe is. And you could say, hey, you're Elias Yudkowsky, you think AI should not be able to do anything.
You think everything is unsafe. I think that's one of the key reasons why we chose to categorize the WMDP dataset as well as just use it. I think the dataset of questions there was actually made by some people who held a very strong opinion that model that is available to a general public shouldn't be able to answer even low risk questions related to bio, cyber, and chem topics specifically. And they held that instead, the general public should have a more censored approach, while people who are safe researchers or verified researchers can have access to a model that has knowledge of bio and cyber and related to their field. But some people may not think the same, and definitely when it comes to products using an open source language model, you want to be able to fine grain your refusal capability. So that's why we chose to do high, medium, low risk. There's actually way more categorizations we need to do. We can categorize by bio cyber. I think it's actually part of it. We can even categorize. We can even explore the specific fields of as seen in the there. So yeah, definitely. Personally, I think when it's open, at least when it's open weights, it shouldn't be censored so much, but that's different for everyone.
Yeah, I think yeah, I guess it's always the question, once you have it public available, like one bad actor can make it pretty bad, even though a lot of people would use it for good. And I think we have some fellows currently working in the lab on research related to like properly categorizing and evaluating datasets as well. So I guess that's like a little part of what you're doing as well, of getting these, like looking at the dataset and actually categorizing it. I think okay, Jazz has a question. If you ran into any problems with getting the LLM to output just safe or unsafe, and how you handled these problems.
I wasn't really assigned to the coding portion. I was more assigned to the writing the paper, but
Yeah.
I think we did not actually run into that problem. You can definitely the prompt matters, right? We prompted the model to say answer only safe or unsafe. I think that might also be an issue if we venture outside of instruct trained models.
Nice. Yeah, and it looks like Carl is
So yeah,
adding context as well.
there's an answer from Carl.
Perfect. All right. Thank you so much to say no to mass destruction team here. Another round of applause for you guys. Thank you so much. Great submission too. And now we are ready to hear from dark patterns in language models.
So, I'm Sammy. I am the humble technical assistant of Jordan Nakash, who did most of the work on this. But I think it's very late/early for them, so I might be just a little bit more awake for doing the presentation bit. So our goal was to extend the work done in a previous APART hackathon project that is about measuring dark patterns in chatbots. So if you're not familiar, dark patterns are dark design patterns are this concept where algorithms can have manipulative capabilities when engaged with users. They'll kind of steer them into certain behavioral patterns that aren't necessarily aligned with the user's intent when they were starting to engage with that chatbot or algorithm. It's been explored a lot in social media, and recently by Park et al. In the previous APART research project explored with chatbots. So our key contributions here were to so the Park et al. Project used conversations sampled from ShareGPT. We instead crafted prompts to specifically elicit certain dark patterns to try to see, like, can we get in the worst case, can we get certain different chatbots to show those behaviors? And we also used, we expanded it to models from both OpenAI and Anthropic, as well as we laid out a pipeline so that you can very easily plug in any model, hopefully soon even open source models or locally hosted models, so that you can both generate conversations and evaluate them using different models. So I'm just going to linger a little bit on this slide and then go pretty quick through the rest. So the chart down here at the bottom, the blue are GPT-4 Turbo responses, Claude 3 Sonnet, and then if it has the crosshatch on it, that means it was evaluated by the other model. So you would have a conversation that was generated by Claude and then evaluated by Claude, a conversation that was generated by Claude and evaluated by ChatGPT, and vice versa. So some of the things that we saw, GPT-4 is really harsh when evaluating. So the middle two bars are the ones that were evaluated by GPT-4, and it is a much harsher critic. We don't know. We can't yet say which is more correct. You would kind of need to validate it against human annotations, which would be a natural next step. Some other so this is an overview of the main results, and there are these different categories of dark patterns that we were specifically targeting. So this is kind of what I just said. Like I said, based on it extends some existing work in algorithmic bias and fairness, and now we have a whole new arena to worry about. So the way this worked is Akash and Jord did a whole bunch of hard work in getting 392 prompts meant to elicit these dark patterns across 8 categories. Starting by asking an LLM to create the prompt and then manually reviewing it and revising it. So those are the prompts, and then you feed each of those prompts to the assistant model, and those we did that with 4 different assistant models, although we only evaluated 2 of them, just kind of demonstrate that the pipeline can work with arbitrary models. You give the prompt, and then you get a response. And the prompt and response together are a conversation. And then you feed the conversation along with an evaluation prompt to the overseer model. So that's this bit down here. And the overseer is meant to evaluate the conversation along these different dark patterns, and it outputs a binary yes-no score in JSON. Although Claude Sonnet really doesn't like making JSON. Even though when you tell it, like, just give me JSON, it's like, nah, I'm gonna stick a little description at the end. So we had to stick a little bit of extra regex parsing because it just really wanted to add extra stuff after the JSON. So these are the experiments, like I said, 2 by 2 for each prompt. There's the assistant and the overseer. So each model both evaluates itself and evaluates the other model. And we, Claude GPT-4 Turbo and Claude 3 Sonnet. We limited it to these two, which I think was a wise decision on Akash and George's part, because we were pretty much running generations the entire weekend, and I don't think we would have had time to do more. So they were wise to just stick it to those two, and that was a good choice. So again, the results. I kind of already discussed these ways that we could go in the future. Again, validate against human evaluations, sample multiple responses per prompt, and see how often those prompts get the dangerous patterns get shown. Measure prompt sensitivity, randomize the order. So we only did one back and forth, but you could have multi-turn conversations. Like, it might be easier to see these behaviors over longer conversations, more models, etc. Lots of ways to take this forward, and luckily we have a nice pipeline now to do that. Related work, like I said, the existing the previous apart research project. This one, the crafted prompts seem to be doing a good job at eliciting the behavior at a higher rate than in normal just shared GPT conversations. So that seems to be working. And I just stuck here at the end. It'd be really cool if there was some kind of clear chat, certified clear chat, little benchmark and badge you could put on your chatbot and say, it's been validated not to try to mess with your brain. That would be nice. That is our project. Questions?
Amazing. Thank you for the presentation, Sammy, and everyone's clapping along with virtual spaces. I guess maybe here at the beginning, I'd be curious to hear just a little bit more about what are the dark patterns you tested for, and is there anything you might have missed, or any reasons for that?
I'm sure there's things we missed. Like I said, there's a lot of existing work in kind of algorithmic bias and fairness, and I think there's definitely an opportunity there to engage deeper with that literature and get some validation of the dark patterns here. But the ones we chose were so answer length is the model trying to give you overly short responses just because it costs the company more to generate longer responses. Anthropomorphization does the chatbot response tend to represent the chatbot as a human in human-like terms, which can be manipulative in terms of we like other people, and it makes it easy for us to forget that we're talking to an algorithm. Brand awareness does the chatbot seem to go out of its way to say nice things about the company that made it. If the bot's like, I'm glad you answered because OpenAI is so glad to be giving you good responses. It's like, hey, what are you doing? Answer length and cost optimization. After we reviewed this, we thought maybe those should be combined. I'll just skip that one. Echo chambers. Parroting back your inferred preferences, just parroting it back at you. Misalignment does it seem to you went there with a certain goal, and does it seem to be trying to get you to change what your goal was when you were engaging with the chatbot. Privacy zuckering is getting you to divulge unnecessary private information about yourself. And user retention is again about this just seemingly trying to get you to come back for reasons that have, very little to do with, hey, I just needed one answer. Why are you? So those are the categories there, and they're described in deeper detail in, I think, both projects. So you can go check this out.
Nice. I think if there's no other questions, we'll be able to jump on to the last project presentation and then sharing the awards afterwards. So if anyone from the rAInbolt project wants to raise their hand and jump on stage.
Good afternoon, everyone. All right. So, how well can LLMs infer locations from an image? Well, this benchmark evaluates the capability of AI models in inferring locations from single images. So we'll give for this benchmark, we tested with GPT-4o. We gave it a single image, and we told it to analyze the image, the elements in the image, and see and guess what might be the coordinates be. So the average distance from the correct coordinates of the image and to the guess coordinates is 2,000 kilometers. But as you can see on the distribution, most of them generally fall below 2,000. And there's some huge error that can go up to 20,000 kilometers. But one of the it can be as close as 400 meters, and that was the image in Mongolia. I'll show that on the next slide. We found out that with a higher volume of, our hypothesis was that higher volume of elements such as languages, signs, street signs, objects that might have a cultural element to it, specific to regions and countries, will have a higher accuracy of the guess coordinates. And also pictures that include famous architecture like maybe the Great Wall of China, for example, or the Eiffel Tower will definitely let the models know that, well, the location is very obvious. So this is the example with Mongolia. So the image is from 47.9 at 106.89. Distance between the guess coordinates and the actual coordinate is just over 200 meters. And as you can see from the image, there's barely any language or elements that immediately gives away that this is Mongolia. So the model, this is GPT-4o, looked at the image and analyzed elements such as vegetation from the trees, the evergreen trees, buildings which can be seen in the background, but it's not very clear. Fencing, which is typical in Eastern Europe or Central Asia, if I'm not wrong. And then the vehicle, which has its number covered, but I guess maybe the models know that this car is very typical in Europe, in European car markets. And then it looked at the environment with the, I guess, like the grass around here, and it's generally clean, it's not really messy. All right. So, this thing, our benchmark looks at the risk of AI models in compromising user privacy and security. Well, let's just say someone has malicious intent and they can just scrape through your social media, for example, get a random image and, well, dox you. Something that rAInbolt, the inspiration for this benchmark, does on his social media account. People give him images and he'll just look at some very small element in the image to guess the coordinates. I hope this highlights the importance of developing robust measures to mitigate these risks and explore inference capabilities of models across different modalities. Yeah, and also analyzing the performance of state-of-the-art models in deducing geographic coordinates from visual inputs. And the impact of image features on prediction accuracy, because in our benchmark, we gathered the response of the model that analyzes the images, and we give it criteria for the guess, which includes climate, architecture, street signs, language, vegetation, vehicle, and urban layout and cultural element. So our methodology was that we had to collect images first, and people in our group scraped the images from Google Street View. In total, that's 1842. And I myself went outside, just walking around the city, and took some photos myself, which account for a very small number. And also, I still have some more images, but I haven't labeled them. We used GPT-4o, and we use in our prompt we ask the model to roleplay as a GeoGuessr player, and we ask it to be logical about their analysis on why they would choose the coordinates and be very specific about the coordinates. And after that, we measured the distance between actual coordinates and guess coordinates, and just that's in the data. So the experiments, we feed single images to models with the prompt mentioned before. This was all done through Colabs, and so we have images from different places. It would include 40 images from Vietnam, some images from Indonesia, India, Switzerland, Korea, Japan, just any places that we can script images on Google Street View. And the output was the guess for the location of images with reasonings, like in the images with Mongolia I've shown. So we have the reasonings of like 5 categories: vegetation, architecture, and then the coordinates at the end. And then we used GPT again to label these images into 9 criteria. That was done with regex. I prompt the model to output only based on this criteria. So I give it 9 criteria categories, and it has to grade the response and put 1 or 0 into each of those. And I use regex to just get all those information and store them in a CSV. So the results of the benchmark, we found out that urban images are way more effective because they have greater amounts of identifiable information. Pictures that has streets, especially pictures with street signs, cultural elements such as the fence, some decorations on building, and significantly help GPT to deduce the location. We also investigate inference rates within different elements of the selected category. In the future, I want to have more category that we can give criteria to the images, as well as categorize the images between like significantly hard to identify, such as images in more like nature scene, for example. Then like they'd only have the vegetation to infer locations. And we also found out that landmarks and climate are the least accurate criteria for inferring locations. So there you have it. Average distance and the criteria. Tree signs almost always guarantees. Tree signs has a very short average distance. It's very small. Landmarks has high average distance. We also see vehicle and cultural elements scoring relatively low. Is the distribution from earlier. The maximum value for average distance difference was the image in Indonesia. In Indonesia, and the model wrongly guessed the image to be in I think some country in Africa because of the tropical vegetation and the rather the farming equipment and stuff like that. Here I'll list some related works. We have some existing research. And vision language models be good guesser. Beyond memorization, language models model us. Various posts related to true side on less wrong. Building upon previous work, we want testing for new large vision language models like GPT-4o and Claude Opus. Unfortunately, we didn't have enough time to test to gather results with Claude. So I'd like to do that in the future. and analysis of image features used to guess location. So I want to add more criteria as well as to classify the source image that was fed to models. Possible future work, sample efficiency for info inference, video frames. Maybe we can feed like multiple frames of one video, or different angles of the same location for even more accurate inference. How much does inference cover exactly? Real-time location and local time, real-time user goals. How could this information be exploited by models? Better feature analysis than just using model responses. Just feature vis and interp. So that's it. Yeah, can't spell rainbow without AI. The project was done by me, Alexander Popov, Jordan Nguyen, Chung Zung Mogu Huang, Marcel M, and Felix Mikhalik. Yeah, that's it. Any questions?
Thank you so much, Alex. Amazing work. Really, really impressive. And for anyone interested in seeing more fun stuff, they can of course check out the project's page too. Are there any questions besides how you can come up with such a cool name for your project, and how others can replicate such name equality? Yeah, so Kyle asks, it would be nice to know if Claude is more performant because Google has Street View to train on. Yeah, I guess that because Google has invested in Anthropic. You saw the difference between
Right.
Claude Opus, right? And yeah, not a question, sorry, but I guess I read it as such.
No. We don't have the data on Claude, unfortunately, but yeah, that I would like to explore if Claude has a better guess and just the performs better in inferencing location.
Another question is like, which other categories could you imagine, and how do you see this performance/reasoning relate to how, I don't know, since you name it Rainbow, maybe you know that you guess a guy and maybe have seen how he reasons. Have you seen these differences between like human and how the AI reasons? Anything specific there?
Right. I think one of the most impressive thing that Rainbow does is he has the time at which the image was taken, and he would compare that with the cloud shape that he gets from the weather image. I think that's pretty insane, and I want to explore that in the future too. So feed it with the timestamp at which the image was taken, and get the weather data of cloud, for example, and make it guess based on the shape of cloud that maybe you know there's like rain cloud over there, so it's gonna be around this area, for example. So the image mostly focused on the street and climate, but it didn't take into information such as cloud shape or shadow shape. I didn't hear a lot of that. I didn't see a lot of that in the responses.
Yeah, it's wild. Humans are also pretty impressive. Do you think it's super intelligent?
Right.
Is it better than human level? Do you guess? I guess it's not expert level then.
I would imagine it could be a better geoguesser than Rainbow. Maybe we can have like a battle between Rainbow versus rAInboltBench and see how well he performs against models. That would be a fun thing to do too.
That is awesome. Yeah, and I guess like any reinforcement learning on like location inference is pretty hardcore. And of course, we're talking about how crazy it is, but it's also just like, as you mentioned, the threat model of all models suddenly knowing where everyone is at any point in time and having a personal rainbow for everyone is pretty wild. Have you thought about like how can we maybe mitigate this in a way where it like can still understand that images have trees in it or whatever?
You mean like it still recognizes elements in the picture, but it doesn't infer the location?
Yeah, like which sort of mitigation measures could you make?
I was looking through the data, and one of the images that throws off the guessing the most was foreign languages. So I had some images from the more artistic side of my city, and it has a lot of graffiti on it, but in different languages. And the model would just wrongly guess the location because of the language. It's like, oh, there's Japanese text on the wall. That's probably Japan. There's like Arabic words on the wall. That's probably somewhere in the Arabic nation. So put some foreign language objects in your photo. Maybe wear like a Japanese shirt all the time when you're not in Japan. That could throw it off a lot.
Nice.
Yeah.
So we should all wear like a T-shirt with Mount Fuji, unless we're at Mount Fuji.
Yeah, Mount Fuji. Yeah.
Awesome. All right. Thank you so much, Kronox, for this talk, and another little round of applause here. A lot of great comments in the chat about blurring backgrounds and
Yes.
also apps for blurring where you are and replacing your background with various items.
Yes. Yes.
Awesome.
Thank you for having me. Thank you.
Of course. Nice. All right. I will just share my screen really quickly. So of course, it's very, very difficult to select the 4 winners here and in which order these projects go, because they're really, really amazing. We've had a great judging team on the task, but still it's difficult to decide. And I just want to, of course, give a massive shout out to all the projects that have been part of the hackathon here, because they were all really, really impressive. And I think in other competitions, not the apart hackathons, but in other competitions, maybe they would have won as well. So I just want to give a really, really big shout out to everyone on that. And without further ado, I want to announce the winner first here. So maybe we can get the absolute loudest piece of everyone slamming their table here and figuring out who's the winner. So drums. And the winner is rAInboltBench. And we just heard the presentation there. Thank you everyone in the chat for all the drums. But yeah, a really, really amazing project. Very impressive that you got so much done and like connected it to the different subcategories. And as Akash mentioned in the chat, this proves that AI researchers actually touch grass and get outside. So thank you, Kronox, for going outside and taking some photos too, adding that to the benchmark. So really, really well done, and great work. Applause there, and everyone's partying in the chat. That's great. Now let's go on to the other projects as well for the second spot. So another little drum roll. So the second place goes to the team we had the first presentation from on cybersecurity persistence benchmark, and this was despite the results not being there. Really, really awesome project and really well motivated and in general well set up. You know, it's quite impressive to actually set up a functional, albeit very slow or at least somewhat slow methodology on Amazon Web Services for a new type of container for running these sorts of challenges and actually getting them up and running. Unfortunately, that Llama models aren't capable enough. So really, really cool methodology, and we have people in the chat as well mentioning that. So great work from you three, David, Felix, and Jeremias. And another little drum roll here for the second spot, or for the third spot, sorry. Bada bing, bada bing. It is the Say No to Mass Destruction. We heard from them as well, but getting this sort of meta perspective on being able to refuse, and there are some refusal benchmarks out there trying to evaluate when do models actually refuse to questions that they should refuse to, and when do they not refuse to questions that they should not refuse to. But in this case, it's actually looking at when do the models understand what the heck they should refuse to answer and not. And so it's quite a novel thing, and I don't think we've seen it any of the judges before in existing research. So great work from the whole team there. So congrats to Alexander, Carl, Joseph, Smiley, and Kyle. Nice. And then the fourth spot, maybe you guessed it, but drum roll anyways. It is the benchmarking dark patterns in LLMs with Jord, Akash, and Sami. Really great work there as well, and extending it, and always great to see people taking a great methodological approach to evaluation and actually getting cross validation between models. And really impressive to extend that work with the new, just with properly updating the. We have Jason in the background here, also saying congrats, but also updating it to actually improve the benchmark in terms of the from this somewhat vague conversational data to this more concrete categorized benchmarking, so you can really elicit it and take that next step in terms of evaluating models for being safe as well, and not just for the statistical propensity naturalistic conversations for these sorts of dark patterns. So congrats to you as well. And we'll be reaching out to everyone mentioned here with prizes, but we'll also be sending out an email to everyone who was involved to hopefully get some feedback from you all. And thank you so much for joining and making all these amazing projects. And then we hope you also want to give some words back to us so we can improve for the next time and make these events even better. And thank you all for all the great emojis in the chat. And then there's of course also a potential for joining the lab. There's already a few lab fellows in the chat right now, but we are gonna reach out around mid to July or so, if not the start of July, for any projects where we're really excited about getting you on and helping you publish that work or publish new work within research domains similar to this benchmarking and evaluation, and hopefully accelerate your research career even more than it already has been during this amazing weekend, and potentially even for next year being ready with a publication to submit to the SafeBench competition, where you can earn massive prizes for making some awesome safety benchmarks. Nice. And some other things you can do as next steps, just so you are not left behind here crying now that you've done your hackathon and you don't know what you're gonna do next. Well, you can of course rewatch the great talk from Bully. We have that live on our YouTube channel, and really amazing talk, and thank you so much to her, of course, for that. And you can think about joining the next hackathon. We already have one actually this weekend, independently organized with Pips. So Pips and Apart here are organizing with the key organizer, Adam Shai, who will give a talk tomorrow, and I believe that is 5:30 p.m. UTC or so. And that'll be, so computational mechanics is a type of is a piece of theory from physics from the 80s or so that you can use to analyze complex systems, and basically look at the data generating process, and then if a process has to predict what is the next step in the data generating process. So in our case, for example, it might be language. What is the next token that comes out of that? Well, in any other data generating process, can we see that the system that learns it will actually learn it in quite a specific way and need to follow this type of model for it. And we can see some very interesting analogies to this complex system analysis in what the neural networks actually learn when they look at these sequences of data. So there's a bunch of stuff there. I'm sure the keynote will make that more clear for you if you join tomorrow. And you can of course sign up on the website there on apartresearch.com/sprints. And then we have another one in a month or so on deception detection. Hopefully we'll get an awesome partner there that some of you might know already, but that is involved in that sort of work. But it's going to be really awesome, and going to be building a little bit on the work we've done this past weekend on actually being able to detect, things and capabilities and potential dangerous capabilities in language models, but also looking at, are there actually cases where they try to deceive us as users or us as researchers, or are there cases in the future where we'll need a very specific structure to be able to detect this? Do we need it? Do we need to use actually white box methods where we look into the model as well? So these are a couple of the next hackathons that we're organizing, and that you are very, very welcome to join. We'd love to have you all come along again, and we'll of course have some great prizes as well for anyone lucky enough to get the top reviews. And we also encourage you to share these ideas on the forums already. There's the EA forum, the Let's Run forum, whatever, where researchers like this congregate. And of course, otherwise also reach out or chat with your teammates if you want to continue the research. And we can also help in any ways related to that. Nice. And thank you so much to all of our friends and partners during this hackathon. So a big thank you goes to Bully for joining us. She's that was amazing, and sharing some of her unpublished work as well with us. So we got an even better overview of what's going on in the field. And thank you to Min and Mateus and Nora and Jacob and Natalia for joining too as judges and giving some awesome reviews that are all live on your project pages as mentioned. And yeah, thank you so much. I think that is all I have to say for now. Thanks for joining, everyone.